Hello.
Good morning, sir.
Very good morning. Sorry for the delay in starting the class. Okay, just a minute. Are you able to see the screen?
Yes, sir.
Yes, sir.
Okay. So today we are going to start the last unit, that is the fifth unit. This unit is completely about the testing process. So as we saw, according to the syllabus or to whatever we have gone up to know, in the first unit, we discussed about the various framework activities. That is, we have totally five framework activities in software engineering: communication, planning, modeling, construction, and finally deployment. As part of the modeling, we are going to have analysis and design. And as part of construction or development, we have coding and testing. So your syllabus is also in the same way. That is, the first unit is completely about the basics and various process models and framework activities. Second unit is about the gathering of requirements. That is, how you plan with various things. That is, it is combination of communication as well as bit of planning also. In the previous syllabus that we have, we used to have something like effort estimation techniques and all those, but they are removed for you people. So the second unit is nothing but combination of communication and planning. Next, third unit is about the modeling process. Modeling contains again analysis and design. So the third unit is about analysis, and fourth unit is about design. So that is about the modeling activity. And after modeling, the next activity is construction. Construction is about coding and testing. So coding is usually done with any of your programming languages, that is by using C, C++, Java, Python, whichever you are having. Those are actually part of your syllabus as a complete subject. Hence, we are not discussing anything about coding. After coding, the next thing is actually this one, that is testing. And after the construction or development, we have last activity, that is the deployment activity, where we transfer or we hand over the application to the customer, and there we maintain some quality assurance. That is, we assure the customer about quality of the product, that it is reliable, it is portable, it is secure, everything in every aspect. We will make sure the customer is happy and assured about the application. That is what we call as software quality assurance. That software quality assurance we'll be discussing as part of this particular unit. So in this unit, we'll be discussing about various testing methods as well as software quality assurance things. Just a moment. So actually, in this unit, we'll be discussing about various testing methods, and we'll be discussing about the software quality assurance as well. So testing methods, coming to testing methods, you already know which is the activity or action that takes long duration in an application development.
Testing.
Testing. Testing.
Yes, testing. The important one is actually design, but the one which is tedious, which takes a lot of time, is testing. We have around 12 testing methods. Each application need to pass at least 8 testing processes to make sure that is a good application. If you want to ensure the customer that is a highly qualified or high quality application, then you need to go through all the 12 testing process that we have. So we'll see those various types of testings in this particular unit only. And coming to examination point of view, you have two types of testing: white box testing and black box testing. Either of them will appear as a question in the examination. If you exclusively think about examination, you'll be asked to explain about white box testing, or you'll be asked to explain about black box testing. So to start off with, first we'll see some introduction before going into the actual topic, that is what is testing, what are its features or characteristics and all that. Okay, so first one doubt here. In this particular thing, we'll be discussing about testing strategies and testing tactics. What is the difference between a strategy and tactic? Anyone? 74?
Strategy.
Uh, s- the strategy is based on which they proceed, like in a situation,
Okay.
and it is usually a little longer than a tactic. Tactic can be a way to get out of the current situation, like an escape plan or something. It can be positive or negative. It
Yes,
can
good.
affect the other person, or
Yeah,
it's
exact
usually
answer.
done. So,
Right. So strategy is something, if we plan for a longer period of time, that is long-term planning is usually called as strategy, and short-term planning is what we call as tactic. Both are nothing but another names for planning. But if we plan for long term, we call that as a strategy. If we plan for short term, we call that as a tactic. So actually, if we test for smaller parts of the application, like individual programs, individual functions, individual classes, then we call them as tactics. If we integrate all these and finally test the application, the bigger one in the picture, then we call that as strategy. Because which is small in units, a particular program or a complete application, which is smaller?
Programs.
Programs. So the testing that we do for that particular programs, those methods we call as testing tactics. And the bigger one is complete application. And testing this application with various scenarios or in various scenarios at your end, at customer end, and all this, which takes some bigger period of time or longer period of time. We call that as a testing strategy. So that's the main difference between strategy and tactic. If it is short term, then we call that as a tactic. If it is long term, then we call it as a strategy. So actually, there was a question: what's the difference between testing strategy and testing tactic? The testing that is done for longer duration, we call that method as testing strategy. The testing that is done for a shorter duration or for a smaller unit or smaller application, we call that as a testing tactic. It's a 2 mark question usually. So first we'll discuss about the strategies before going into tactics. A strategic approach to testing. Testing is the process of exercising a program with the specific intent of finding errors prior to deliver to the end user. At the end of every program, while you write in Java, C or C++, what is the last thing that you are going to do? After completion of the program, what is the thing that you are going to do?
Compile.
What is the purpose of compilation?
Checking for errors.
Yes, very good. So we'll compile the program and the purpose is checking for the errors. That is simply what we call as testing. Testing is nothing but checking for the errors. If you go for C language or C++, we use F9. For Java, we use Java C. And I mean, those things are actually used to compile your application where you are going to detect if there are any errors and you can fix them before executing the program. And the same thing applies even for a bigger application as well. If you want to make sure the application does not have any errors or any bugs, then definitely you need to test that application in all the possible manners, because here, while writing the program, the person who is going to suffer if there are any errors is yourself. That is, no damage to any other person or no discomfort to any other person. But coming to an application, if your particular application that you developed has many errors, then the user is going to suffer a lot, and that is going to be a big problem to your organization fame as well. Because if the user faces those errors, will he be interested to come back for renewal of the application or for a development of new version back to your organization? Definitely no. Because on seeing those errors, he will come to a conclusion. I made a mistake by giving this particular project to this company. I would not go back to them again. So it is the important thing for every developer that he need to make sure that there are no errors in that particular application. So many of you will ask, sir, if that is the case, then uh, why we need to do the maintenance thing? That is, what is maintenance actually? As part of deployment, we'll be doing the maintenance. What is maintenance? ఎవరికైనా
If any,
గుర్తుందమ్మా మెయింటెనెన్స్
if
అంటే
any,
ఏంటనేది?
if any errors
Sir, we
occur in
have to
between, maintain
maintain
the
the program as per the contract, sir. Like for 5 years or 10 years. For it
Yeah,
maintenance, like suppose if it's not working or anything, he has to make changes. Then he can ask
yeah,
it for it.
yes. So maintenance is about basically fixing the bugs if it is not working or getting any errors, what to do. So after testing, we'll not get any errors. After this thorough testing, we'll not get any errors. But still, why we need to do maintenance means the customer's application or the customer's system or the environment might not be the same always. Sometimes he might be working at home where the application is running fine. Sometimes he might be working at the office, application runs fine. Suppose that person has gone to some internet center. In that case, he will not have the same configuration and everything. The application doesn't work. Then immediately he will get back to you and he will ask you why it is not working. So maintenance is always about compatibility of the application, where it is not about some syntactic error or semantic error. It is basically about usability error. That is, the user might not know how to use the application, how to access the application in different environments and different scenarios. So that's why even though there are no errors after the testing of the application, it is important to maintain any application. But coming to this particular slide, the testing process is nothing but checking for errors. That is very simple definition, most of you know. Next, a strategy for software testing integrates the design of software test cases into a well-planned series of steps that result in successful development of the software. The strategy incorporates test planning, test case design, test execution, and result collection and evaluation. So here, the testing strategy, that is the process of testing, contains four things. First one is test planning. So that is, you need to plan when to conduct unit test. You need to plan when to conduct validation test. You need to plan when to conduct integration test. So one simple logical thing, will we do single unit testing, that is single programming testing first, or will we go for integration testing, that is testing of entire application first? Which one will do?
single unit
Single
testing.
unit testing.
Right, single unit testing. Like that, we'll be doing all the programs. Then we'll be combining them and go for integration testing. As we have many testing process, we need to plan each one at which particular day, which testing process should be completed. Next one is test case design. Test case design అంటే ఇక్కడ కన్ఫ్యూజ్ అవ్వద్దు, వెరీ సింపుల్. గివింగ్ ఇన్పుట్స్, గెటింగ్ అవుట్పుట్స్ is what we call as a test case. Test case is nothing but when it is a combination of inputs and outputs. When we give correct inputs, are we getting correct outputs or not? That is what we mean by a test case. In your record, in your observation notes or record, what do you do for every program? After writing the program, you write set of inputs and set of outputs. Those are what we call as the test cases. Now, test case design is nothing but, so what are the set of inputs that you want to give? What are the set of outputs you are expecting to get? If you get those expected outputs, then you can say the application does not have any syntactical errors at least. Next, after designing this, after having this on paper as well as on mind, we'll go for the execution of the test. And if there are no errors during the compilation, and if it gives the proper output, then we can say the test execution as well as test result collection and evaluation is completed successfully. So the testing process, what we simply do in programming, it contains these four things also. First one is test planning. మీరు ప్రోగ్రామ్ లో టెస్ట్ ఎప్పుడు చేస్తారమ్మా? When you will go for testing while you write a program?
After compilation.
No.
Sir, after we compile, then we execute it. No, sir.
No. Not the correct answer. When you will do testing while writing a program, suppose you are writing something addition of two numbers, you are writing a program. Test ఎప్పుడు చేయాలనుకుంటారు మీరు? Simple question. What is after execution? What do you mean by execution?
The code.
Sorry, Amisha.
Execute the code.
No, that's not correct. I am asking a basic question, simple question. Even a first year student can answer. When you want to test the program,
Sir, after writing the source code, then compiling it,
Right.
then executing.
yes, what do you mean by compiling and executing? I don't understand. In compilation, what do you do?
Sir, it
For
checks
che-
for
for checking an
syntax
error.
error.
That's it. That is what we call as testing. Then why we go for after compilation, and again why we go for executing and all that? After writing the program,
Sir.
after writing the source code, we'll go for testing. Yes or no?
Yes, sir.
Yes, sir.
That is what we call
Sir,
as
we
test
can check
plan.
it after
We can check
if
it.
there are any logical errors in the program.
That is later on. Initially, we'll plan for the test. మనం ఏమనుకుంటాం, what we have in our mind, what we have in our mind, we need to test immediately after writing the code. We can't go until execution. First, we need to compile,
Okay.
then only we'll move for the execution, where we'll check for logical errors. But syntactic errors should be checked or compiled or fixed immediately after writing the code. Do you agree with this?
Yes, sir.
Yes, sir.
So that is what we usually what we think in our mind. We call that as test planning. Next, after compilation, successful compilation, we'll give set of inputs and we'll expect some outputs. That is what we call as test case design. And after test execution, that is after successful compilation, we'll be giving those inputs and we'll get the output. And that is what we call as test result collection and evaluation. If we get correct outputs, then we can say the program is a successful one. So what we regularly do, that is what we call as test strategy. But the thing is, if we do for a bigger application, we call that as strategy. If we do for a smaller program, we call that as a tactic. That is the only difference. Next, some generic characteristics, that is, to perform effective testing, a software team should conduct effective formal technical reviews. That is, you need to have meetings within your team every now and you need to assign specific test process to specific members. That is nothing but who need to go for acceptance testing, who need to go for unit testing, who need to do integration testing. Obviously, team leader will do the integration testing process because he is the senior and he knows how to integrate various things in the program and he will test that properly. Like that, you will assign work to each of these members in those meetings, which we call as formal technical reviews. Next, test begins at the component level and work outward towards the integration of the entire computer-based system. This is what we were discussing earlier. We start from a single unit, that is a single program or single component, and finally we'll integrate the complete application, that is complete components, to get the complete application. That will be again tested. Because Individually, those components might work fine, but while integrating them, if your connection, if your relation is not good enough, if the connection, let us say, connection between front end and back end using Java database connectivity is not successful, then are you going to get correct outputs? Is the database going to give you correct values?
No, sir.
No. I think in WIT you have this JDBC, Java database connectivity, right? So even
Yes, sir.
individually the components might perform well, they will be without any errors. Can you hear me?
Yes, sir.
Yes, sir.
Yeah. Individually components might be without errors, but we need to make sure after integration as a single application also they are working fine. That is the most important one. Next, testing is conducted by the developer of the software, and that is for large projects by an independent test group. That is nothing but nowadays if you have a startup company, the developer is going to perform two things. One is he is going to write the program as well as he is going to test the application, because the number of employees in such companies will be less. So one person need to do multiple things. Whereas if we have a bigger organization, level 5 organization, then there will be separate members who, I mean, separate software engineers who are especially going to test the application, whom we call as testers. And set of those members we call as ITG, that is independent test group. So what I mean to say is, in small organizations, developer will do dual action. He is going to write the program as well as test the program. But if it is a larger organization, testers are going to test the application. And next, testing and debugging are different activities, but debugging must be accommodated in any testing strategy. That is, testing is when we develop the application, and debugging is when we maintain the application. Remember the difference. Both are actually finding the bugs, finding the errors, but testing will be done during development of the application, whereas debugging will be done during deployment of the application. Did you understand the difference, guys?
Yes, sir.
Yes.
Yes, sir.
Yeah, 76. Differentiate testing and debugging. Seventy-six is not present. 71. Tarun,
Yes, sir.
what's the difference between testing and debugging? Seventy-three. Jagdish.
So testing is done in the development of application,
Hmm.
where debugging is done at the deployment level.
Yes, good. So if we test during development of the application, we call it as testing. If we test during maintenance, that is deployment of the application, we call that as debugging. So both are same or similar, but one is during the development, other one is after the development is completed. So these are the basic characteristics, but the important one that you need to remember is, first each unit, each component of the application should be tested. Then we need to go for integration and we need to test them again. That is the key thing in this generic characteristics. Next. So next one is verification and validation. These are two types of testing process. So here, most of you might have heard about these two terms in general, but coming to testing process, we have slight difference. I mean, we feel that both are same only, both are verifying certain things only. But coming to the testing, we have slight difference here. Verification is, are we building the product right? That is nothing but, while developing the application, are we developing the product in a correct manner? Are we going according to the given data structures and given algorithms properly? So that will be checked during verification. Whereas coming to validation, it checks the requirements according to user's thought process. Are we whatever? Yes, we are writing the coding, everything fine, everything is correct, everything is verified properly. But whatever you write, whatever coding you have done, whatever models you have designed, are they according to users' expectation or not? That is what we call as validation. And that is, are we building the right product? Yes, we are doing the process right, but is it going to result in correct output or not? That is what we call as validation. Is the difference clear, guys?
Sir, once can you repeat?
Yeah, sure.
Sir,
So
please say validation, sir.
verification is nothing but are we doing the process in a correct manner or not? Are we doing
No, sir.
yeah, just a moment. I'm answering to Amisha's question. She asked you to repeat once more, so I'm repeating verification. Then I'll go to validation. So verification is nothing but are we doing the process right? Are we designing the models in a correct manner? Are we writing the code in a proper manner? Are we integrating them everything in a correct manner or not? Checking the process while designing or developing the application is what we call as verification. Now, checking your particular code, checking your particular design against the customer requirements, against the user requirements, whether whatever we have designed, whatever application we have coded, is it according to the customer requirements or not? Checking that is what we call as validation. Is it clear now?
Yes, sir.
Yes, sir.
So checking the process is called what we call as verification. Checking the application is according to user requirements or not is what we call as validation. So that is what we call as are we building the product right? That is, are we using the right procedure or not? That is what we call as verification. Are we building the right product? So whatever we develop, is it correct or not? Is it according to user requirements or not? That is what we call as validation. Yes, everything is fine, entire process is correct, but it is not according to user's expectation. Will he accept that?
No, sir.
No, sir.
Sir.
The importance of validation. That is, before deploying your application to the customer, you need to make sure whatever you have done that meets the requirements of the customer, and that is what we call as validation. So please write down this particular slide about verification and validation. This is also very important to my question. Differentiate verification and validation. If you are checking the procedure, that is verification. If you are checking application against user requirements, that is validation. Please write down these 2 points. Completed?
Yes, sir.
Sir, 1 second, sir.
Okay.
Sir, how this software designers developing environment will be, sir? Like for every user, we have different versions of um, devices now. So how can they work in all? How do they make it such a way? Like, do they have to make it every time for a separate device?
No, actually, for designing, it will be common. We write those constraints while coding the thing. That by using the if statement or by using switch case statement, we write separate statements for different levels of users. If the particular user is a beginner, then we'll be writing the code according to that particular type of user. So it depends on coding rather than on designing. Designing the components will be the same, but writing it will be different. I mean, for the okay, sir. Thank you, sir. So for the coding, there will be the change.
Okay.
Hope I am clear.
Yes, sir. But how does the software work from different platforms? Not platform devices, sir. Suppose a device is like a new version, as they have the software designers, and then they have like the customer has an older version.
Customer has an older version means that we need to. I mean, you're asking about design or you're asking about coding. I'm not getting your question. Your question
No,
is
sir.
how
The
does it
overall
work in different?
software
How does it
needs
work in
to
different
implement.
environment? That's what your question, right?
Yes, sir.
So while designing the user interface, then there we can make sure that whatever you're designing that applies the same for a mobile phone or same for a desktop or tab or laptop. So there, while you're designing the user interface, you might be writing some HTML code when you convert that design into reality. So while writing that HTML code or DHTML code, there we mention what are the devices in which that should use. That is the screen resolution we'll be having, what are the pixels. We don't mention the device names, but that particular HTML application, whatever you are designing as UI, that applies for various resolutions. Like for mobile phone, it will be something like 1020 into so and so. For a normal computer, it will be some 1680 into 1020, like that. So for different resolutions, we'll make sure that application works.
Okay.
Here it is not about design part, rather than it will be about coding part, that we make that application is compatible in every environment. So designing is properly about only, I mean, we can't write any conditional statements, we can't mention all these conditions such that it should work for so and so people or it should work in so and so environment. Most of that particular thing will be usually done during coding only, and that also during coding the front end. That is, if you want your application to work for set of users, you write that in your programming language. If you want to make sure that works for some set of devices, you write that in a styling language like HTML, DHTML, or XML. Is that
Okay,
okay?
sir.
Yeah.
Yes, sir.
So after verification and validation, next thing is organizing for software testing. That is, when we test, what are the common assumptions that we have and how it actually goes. So that is organizing for software testing. So the testing should aim at breaking the software. That is, the bigger application should be usually divided into smaller components. Then testing of the components will be easy initially. Later on, once all the components are tested successfully, then we can go for complete application testing. That is what we say, testing should aim at breaking the software. What is the reason for this? I think I discussed this already during one concept, WBS, work breakdown structure. Why we need to go for work breakdown structure? There I initially said why we need to break the software. Does anyone remember? Am I audible?
Yes, sir.
So if your application is too big, then identifying the errors, is it going to be complex or is it going to be simple?
Complex, sir.
Complex.
So in order to have a simple, I mean, in order to get our task cut out or make it simple, what we do is we divide our application into modules, modules into phases, phases into activities, and activities into actions. So in the same manner, even while testing also, we need to make sure the entire application is not tested in the initial phase. First, we'll test small components, that is small function blocks or small programs. Later on, when we move to the end, that is when we move near the deadline, then we'll integrate the complete application and we'll test that. That is what we mean by breaking the software. Next, the common misconceptions, that is nothing but common assumptions from outside world. The developer of software should do no testing at all. So this is what we feel. For designing, we have designer. For analyzing, we have analyst. For developing, we have developer. Should also be done by. Whom?
Tester.
Tester. But is it true if it is a smaller organization and a new organization? Can we
No,
expect separate people to do separate works?
No, sir.
We have
No, sir.
only mostly one person all rounder. So they will take a fresher and they will ask that person to perform all the tasks, ask him to design, and then go for development and then go for testing. So this is one assumption which is not correct. Next, the software should be given to a secret team of testers who will test it unmercifully. So this is one more assumption that testing will never done be secretly. It will be done openly only because when there are some, I mean, now we can see even during your labs also, most of you will do silly mistakes, and sometimes even the faculty might not find it out. Okay, so some other person might come in like a lab programmer, and he might identify that there is no semicolon or there is no some apostrophe, something like that. So when it is done in an open environment among all the testing group, then if not one person, the others might identify what is the error from where we got that particular issue. So it is not done in a separate place by secret team of testers. It will be usually done as a daily routine in the organization where they usually work. Next, the testers get involved with the project only when the testing steps are about to begin. So this is one more misconception. That is nothing but testers will be part of the application from the starting onwards only. Okay, so because we cannot give the salary only for testing process. If they are part of the organization, they will be in the complete duration of the project. But they will know the project flow from the starting onwards. If they involve from the day one, it will be easy for them to identify from where they got the error. So we won't involve the testers only during testing phase, but they will be part of the application from starting onwards. So reality, here ITG is independent test group, that is nothing but group of testers. So removes the inherent problems associated with letting the builder test the software that has been built. So that is nothing but here, if there are any problems associated with this, they make sure that the developer tells those issues to these people so that they can sort them easily. Next, works closely with the software developer during analysis and design to ensure that thorough testing occurs. So that is this is one more thing that is opposite to the last point that we have seen. Testers also will be part during analysis, design, as well as development, that is coding, so that they can ensure thorough testing process actually takes place. And integrated tester group or independent tester group is a part of software development project team in the sense that it becomes involved during analysis and design and stays involved through the large project. So what I mean to say is testers are not only involved during testing, but they are involved during entire process of the application. Is it true or false?
True, sir.
sir.
So we won't pay them only for testing the application. We'll pay for entire application duration. Hence, they also will take place in the, I mean, from first of the project to ending, that is delivery of the project. Next one is, so up to here we saw the introduction, and from here the main concept about testing strategies. So these are the four levels of testing software, that is conventional software, are the four levels of testing that we usually have for any application. And if you observe this architecture, are you getting something into your mind? What is this architecture style?
Layer.
Yes, very good. We have five architectural styles we saw in the fourth unit. I don't know if you remember them or not, but you need to read them for the slip test because the portion is fourth unit. So from eighth onwards, you have the slip test, right? At least for that, you need to go through this. So coming back to the topic, we have five styles: data flow, data centered, object oriented, call and return, and the last one is layered architecture. And which one is best among those five?
Layered architecture.
Layered.
What is the reason?
Because it consists of front end, back end, user interface.
Not exactly.
Processes are done in layer OS.
Yes, so the process or the tasks or the methodologies are done one layer after another. So it makes sure nothing in the application is missed or nothing is unknown in the application. And mainly because software engineering follows the layered architecture, it is better for us to follow layered architecture wherever it is applicable. Maybe in designing an architecture or maybe in testing the software. So you can see we have the same four layers which we saw in the first unit in software engineering, a layered architecture, we have seen four only. And the same here, we add them, we take them here. So it is actually bottom to top approach. At the bottom, we have unit testing. Unit testing is nothing but testing the code, testing the individual programs, individual units of code that you have written. That is what we call as unit testing. Above unit testing, we have integration testing. That is combining various sets of programs or individual programs gives us the integration testing. That is nothing but testing the complete structure of your application, the complete front end or the design of your application. That is what we call as integration testing. Next one is validation testing. Just now we have seen what is validation. What do you mean by validation?
Up to the user expectation.
So
Software built is
The product is right.
product is according to the user requirements or not. Product is built according to customer requirements or not. So that is what we call as validation testing. And at the top of the tree, we have system testing. What system testing does is it checks whether your coding is perfect, whether your design is perfect, whether your environment is correct, whether you're doing everything according to user requirements, all these things, and whether your hardware setup, your internet setup, your even furniture, even electricity, all those things are proper or not. Those things will be tested during system testing. So why I'm saying about electricity here is we have called one testing that is smoke testing. Smoke testing means if there is any power failure, will your application survive for that or not? That will also be tested because today your application is running fine, everything is okay. Suppose you have the database server at your end, customer is operating from his system. Today everything is fine. Suppose today night there is a short circuit in your office and everything is burnt. So what happens to your database server?
It gets destroyed.
It gets destroyed or there will be an issue because everything is burnt, the server will be crashed, the hard disk will be crashed.
Yes, sir.
In that case, can the user retrieve any data?
No, sir.
No,
No.
sir.
no.
So we need to make sure in whichever environment we are doing the application, our database server is as safe as possible from power failures. And that is what we call as smoke testing. And it is actually part of the system testing. So system testing does mean it is not only about your software, not only about your application, but sorry guys, got a call. So it is also about external factors such as a power failure, such as a tsunami, such as earthquake. From all this, we need to save our database servers, and that is actually a part of the system testing. So from bottom to top, what we are doing is we are testing the smallest part, that is a program at unit testing, and at the end with the system testing, we are testing entire application along with various external factors as well. And this is the strategy that we follow while we test any even the latest softwares. Also, we go for the same procedure. First, we go with unit testing, then we'll move to integration testing, then we'll go to validation testing, and finally, we'll finish the application process testing with system testing. At unit testing, we'll test the code part. At integration testing, we'll test the design, that is combination of every code and every component. At validation testing, we'll test with the user requirements. Whatever we have done, is it matching the customer requirements or not? And at system testing, we'll go for system engineering. That is our system, our application. Is it compatible with external factors or not? That will be tested. So please take a note of this diagram. Then we'll discuss about these 4 types of testings one after other in detail. So please take a note of this particular diagram, because in examination you will be asked what are the 4 types of testing for a conventional software. Then you need to write these 4 along with this diagram. Yes, give your attendance. 61. 62.
Present, sir.
Present, sir.
Present, sir.
65. 66.
Sir, 61 present, sir.
ఏమైతే లేట్గా రియాక్ట్ అవుతున్నావు?
Sir, mic work చేయలేదు, sir.
ఓకే. 65. Abbas. 66.
Present, sir.
67. 68. 69. 70.
Present, sir.
71.
Yes, sir.
72.
Present, sir.
73.
Present, sir.
75.
Present, sir.
Present, sir.
77.
77 present. 77 present, sir.
78.
78
79.
79
ఏమైంది
present, sir.
మణికంఠ? మణికంఠ ఒక 2 weeks నుంచి రావట్లేదు క్లాసెస్ కి, ల్యాబ్స్ కి. వాట్ హ్యాపెండ్?
సార్ యాక్చువల్గా బయటికి వెళ్ళిండే సార్, సో రాలేదు.
బయటికి
అంటే అమ్మమ్మ వాళ్ళ ఊరికి వెళ్ళిండే సార్, అమ్మమ్మకి బాగాలేకపోతే.
ఓకే. నెట్ లేదా అక్కడ మరి?
అక్కడ సిగ్నల్ తక్కువ సార్, కనెక్షన్ ప్రాబ్లం ఉండే, సో రాలేదు.
ఓకే, నో ఇష్యూ. 80. శ్రీకాంత్.
Present, sir.
81.
Present, sir.
82.
Present, sir.
83.
Present, sir.
84.
Present, sir.
85.
Present, sir.
86. 87. 88.
Present, sir.
89.
Present, sir.
90. 91.
Present, sir.
92.
Present, sir.
93.
Present, sir.
4.
Present, sir.
95. Shiva. 96.
Present, sir.
97.
Present, sir.
98.
Present, sir.
99.
Present, sir.
100.
Present, sir.
101. 2.
Present, sir.
Present, sir.
4.
4 present, sir.
5.
Present, sir.
7.
Present, sir.
8. 9. 7. 10. 11. 12.
12 present, sir.
13. 14.
Present, sir.
15.
Present, sir.
16.
Present, sir.
17.
Present, sir.
8.
Present, sir.
118. 19. 20. Sorry, 307.
Present, sir.
308.
Present, sir.
309. 310.
Present, sir.
311.
Present, sir.
312. 313.
Present, sir.
16 batch 81.
Present, sir.
108. 110.
Present, sir.
Okay. Pradeep?
Sir, 67 present, sir.
Okay. Pradeep? 79.